We start off with the chapter Conic section from section B. And in this class, we will be discussing all the three different conics that we have, that is parabola, ellipse, and hyperbola. And we are going to talk about general equation of second degree, although that is not part of the syllabus, but we are just going to throw some light on that topic. Now, to begin with parabola. Now, how to define it? Now, parabola is basically, it is locus of a moving point, that is a path defined by a moving point, which is equidistant from a fixed point and a fixed line. So now if we go back to the definition of a circle, you'll remember that circle is defined by locus of a moving point, which is equidistant from a fixed point. So there is only one fixed point that is involved, but in this case of parabola, we have a fixed point and a fixed line. Okay, that fixed point is called a focus. So in case of circle, we were calling it a center, but here in this case, we are calling it a focus. And the fixed line, we are calling it a directrix. Now, before we move on to further discussion, now let us just give you this idea that the idea of focus, directrix, and this is going to become base for all the discussion that we are going to do in the future. Not only just in case of parabola, but definitely in case of the other conics as well. So now, once we have understood what is focus and what is a directrix, now the line which is perpendicular to the directrix and passing through the focus is called the axis of the parabola. And then the point where the axis intersects the parabola, that is called the vertex of the parabola. So let us just picture all these things in the figure that we have next to the text. So you can see first figure is giving you the definition. So that is basically that the fixed point, that is the focus, and the fixed line, that is the directrix. So if we take any point on the curve and try finding the distance from that point to the focus and the perpendicular distance from the directrix, we'll see that they are exactly equal. And also here we have in the second picture the all different features, that is the directrix, the vertex, the focus, and the axis. Fine. Now, once we have understood what the figure is, the next thing that we need to understand is the equation. So we will be moving on to the equation of parabola. Now, from the given idea, parabola can be of so many different kinds. So to begin with the first kind, that is the parabola whose axis is the positive x-axis and the vertex is at origin. Now remember, in case of circle, when the center was at the origin, the equation of circle was something, and when the center shifted to somewhere else, the equation changed. So similarly here, the parameter for which the whole equation will depend, that is the vertex. So the position of the vertex of the parabola is very important. So if the vertex is at origin and the positive x-axis is considered to be the axis of parabola, then the equation or the situation will look something like this. That this is the parabola, this is the black lines are the axis, and the blue line that is on the left, that is your directrix, right? Now the equation is given by y square equals to 4ax, and the moment we have this equation, that is y square equals to 4ax, then what are the things that we know? We can definitely tell for sure that the vertex is at 0, 0, that is the center, is at the origin. Then the focus is at a comma 0. Then the equation of directrix, that is x plus a equals to 0. The length of latus rectum. Now, obviously, we didn't talk about this. What is latus rectum? Latus rectum is basically the line segment which, or rather to say the chord, which is perpendicular to the axis of parabola, or rather to say parallel to the directrix and passing through the focus. So that is called the latest rectum, right? So length of the latest rectum will be 4a, or 4 times a. Then if the parabola is having an axis parallel to x-axis and the vertex is, instead of at 0 0, if it changes into some arbitrary point, that's, let's say, h comma k, then what happens? The same equation will become y minus k whole square is equals to 4a x minus h. Just tally this same thing with the equation of circle. In case of circle, if the center would have shifted from the origin to some point h comma k, then it would have become x minus h whole square plus y minus k whole square equals to r square, if you remember. So similarly, the same thing is happening here. What is happening? That is, the equation is becoming y minus k whole square, that is equals to 4a x minus h. So if that happens, then what are the changes that we have? So we will have the vertex at h comma k, which is obvious. Then the focus will become h plus a comma k. So as if like we are just adding h comma k to the whole thing. Then the equation of directrix will become x plus a equals to h. So it was 0 previously, but now it will become h. And length of the latest rectum won't change because it's a length and the length remains same. Now let us move to the second one. Let us take the same thing, that is, the vertex is at origin but the axis becomes negative x-axis. So the figure looks something like this. So what will be the equation now? The equation will be y square equals to minus 4ax. So from here, what are the things that we come to know? So these are the 4 things that we come to know. Now, I think now it is pretty obvious for us to understand why. Now let us move to the next part, that is, if the center changes, or the vertex is at h comma k and the axis is parallel to the negative x-axis. So in that case, the equation will be all the same, but there will be x minus h and y minus k. And similarly, the vertex will be this, the focus will be this and this. So similarly, there are other 2 cases. So let us just go through those cases. That is, one is if the axis is positive y-axis and the vertex is at origin, the situation looks something like this. So equation will be x squared equals to 4ay, and from here I get the vertex is at 0 0, focus is at 0a, directrix will be y plus a equals to 0, and length of latest rectum remains the same, 4a. And again, if the vertex changes from 0 0 to some arbitrary h comma k with positive direction of y-axis as the axis, then the same change, x minus h whole square equals to 4a times y minus k, and the vertex, focus, directrix, and the length of the latest rectum will change accordingly. So now let us give you for the last type, that is the negative y-axis being the axis. So the situation will look something like this. Equation will become x squared equals to minus 4ay, and these are the details that we come to know. And similarly, if we have equation same thing but different vertex, that is h comma k, then the situation is something like this. So now let us move to the problems, simple problems that we have, and let us discuss some of them. Now obviously, according to the reduced syllabus, so we are just dealing with the basic problems. We are not going to go deep into the topic because there are so many things that we have to the chapter which have been removed from your syllabus given the pandemic. So we are just sticking to just the basics. The first one is find the focus axis of parabola, the equation of directrix and the length of the lattice rectum of the following parabolas. So y square equals to 12x, that is the first one. So these are the questions that we have taken. So we are going to solve it one by one. So now the first one is in the form y square equals to 4ax. So if we compare with this equation, then we get the 4a equals to 12. So the value of a becomes 3. So from here, what we get, the focus is 3 comma 0. What is the axis of parabola? Obviously it is the positive x-axis. Then equation of directrix, that is x plus 3 equals to 0. And then we have the length of lattice rectum, that is 4a, that is 12 units. So these are the things we were asked to find out. Next, let us take the second one. In the second one, it is of the type y square equals to minus 4ax. So if we compare, we get the value of a as 2. From there, the focus comes out to minus 2 comma 0, just because it is on the negative x-axis. Then axis of parabola is negative x-axis, that we have already told. Equation of directrix is x minus 2 equals to 0. And length of lattice rectum is 8 units. So third one, if we just do it similarly, this is what you are supposed to come across. Now let us move to number 2. Find the equation of a parabola whose vertex is 0, 0, passing through 2, 3, and axis is along x-axis. So there are quite some information given. So it is given that the vertex is at 0, 0, passing through the point 2, 3, and axis is along x-axis. So if the vertex is at 0, 0, and axis is along x-axis, so we can consider the equation to be y square equals to 4ax, because that is the general form in that case. Now it is told that it is passing through 2, 3. So just let us put it in and find the value of a. The value of a is coming out to be your 9 by 8. So therefore, all we need to do is put it back into the equation, and therefore your equation is 2y square is equals to 9x. So that is your equation of the parabola. Let us move to number 3. Find the vertex, directrix, focus of the parabola y square minus 8y minus x plus 19 equals to 0. Now, as you can see, it is not given in the standard form that we know. So we have to reduce it down to the standard form, and then we need to work. So y square minus 8y minus x plus 19 equals to 0. So if we can just work a little bit from here. So you see y square minus 8y. So we will try to complete the square by taking 16 from 19. So left out 3 will be there. So this gives you y minus 4 whole square equals to x minus 3. Now to get to the standard form, that is y minus k whole square equals to 4ax minus h, that is the standard form that we know. So this is the standard form that we have. So from here I can say the vertex is 3, 4, because that is h, k, that is your vertex. Then we have focus. Focus is h plus a, k. So therefore that is your focus. Then equation of directrix, that is x plus a equals to h. So therefore that is your equation of directrix there. So these are the three things that which you were asked to find. Fine. So now let us move to the next conic, that is an ellipse. Now I had to shift to this just because typing was really hectic. Now let us start with ellipse. Now once we have already understood parabola, then understanding ellipse is not that difficult. The idea is almost the same. Now what was parabola, if we remember? Just let me just draw it on the side. So there is a curve, or there is a moving point, which is moving in certain path, and how it is moving, that there is a fixed point somewhere and there is a fixed line somewhere. So these these two things are fixed. It is already there. So one is, the fixed point is called a focus, the fixed line is called a directrix. Now this moving point is moving in such a way that the path traced out by that moving point is such that the distance of an arbitrary point from the fixed point is equal to the distance of that same point from the fixed line. So that is called, now this looks straight, I mean it looks perpendicular, but definitely it is not perpendicular, it can be any line. So sorry, the point could have been here as well. In any case, this distance is equals to this distance. Fine. Now the same thing is applied here as well, but in this case it is little bit different. The difference being, in case of an ellipse we have the same concept. There is a fixed point, there is a fixed line, and as ellipse is a closed figure, the same thing is there on the other side as well. So that fixed point is here as well, and it is also here as well, the fixed line. Fine. Now if I take any point on this particular curve, then what happens? The distance from the fixed point to the fixed line bears a ratio. It is not equal anymore, but it bears a ratio. So how it looks like? SP is equals to EPM. This ratio is denoted by E, and also we can write it something like that. SP by PM is equals to E by 1, or E is to 1, in whichever. So we don't write E is to 1, we just write E. So this E is called the eccentricity. Eccentricity. Fine. So the same way, if I would have drawn this from this focus, if I would have drawn if I would have taken the distance, and then I would have had to take the distance on this side, then this S dash P, the same thing would have happened. S dash P is equals to EPM dash. The same ratio, whatever this ratio is. Now, this ratio has got a characteristic. What is the characteristic? E is always less than 1. Fine. So if E becomes equal to 1, then SP becomes equal to PM, then it becomes a parabola. But in case of an ellipse, the ratio is always less than 1. Fine. Now, once we have understood the definition of an ellipse, the next thing comes is its equation and the different other aspects that we have. So to start off with, we are considering ellipse with its center at origin. So ellipse is a closed figure, so it also has got a center. So center is at origin. So now we are trying to find out the equation. So equation of an ellipse with center at origin, which is important, we need to mention where the center is, and the major axis. Now obviously the difference between ellipse and the circle is, in case of circle, the distance from the center to the circumference of the circle is always same, and we call it a radius. But in case of ellipse, it is not same. So the point where it is maximum, that is called the semi-major axis. This part is called the semi-major axis. If I take it completely, then it is called the major axis. And the distance from the center to the circumference of the ellipse, where it is minimum, it is called the semi-minor axis. If I take it completely, then we are calling it as the minor axis. So whenever we are trying to find out the equation of an ellipse, there are two things that we need to know. First is where the center is, and which where I am taking the major axis. Whichever, if I talk about major axis, then I can also find where the minor axis is, because major axis and minor axis, they are always perpendicular. Fine. So my first equation, first special case, that is equation of an ellipse with center at origin and major axis as x-axis. Fine. If I consider the x-axis as the major axis. Now, there are certain conventions that we need to follow. We are always going to term the major axis with the letter, we are going to denote the major axis with the letter A and the minor axis with the letter B. So this equation becomes x square by a square plus y square by b square is equals to 1. Fine. Where 2a is the length of the major axis and 2b is the length of the minor axis. Fine. Now, if we are given an equation something like this, now we need to find out all the different parts of the ellipse. How to find it? So let us start one by one. Number one is the center, which is obviously stated already. The center is the origin. If I look at this equation from here, I can say the center is at origin. Then comes the vertex. Now, what is the meaning of vertex? Vertex is those 2 points where the ellipse intersects the axis, the major axis. Now, I could have taken these 2 points as well, where it is intersecting the y-axis, but as we have considered the major axis as x-axis, we are going to focus on the x-axis only. We don't have much to do with the y-axis. So therefore, what are the vertex? Sorry, now here I have to be correct with the English. It is vertices, not vertex. Why? Because there are 2 of them. So we are going to have 2. So vertices, not vertex. So one is a comma 0, the other one is minus a comma 0. So you could have written at plus minus a comma 0. Both would have been same. Next comes is the focus. Now once again there are 2 different foci. So the plural of focus is foci. So we are going to call it foci. A4ci. Foci. And what is the coordinate of the foci? It is a e comma 0 and minus a e comma 0. Fine. So these are the foci. Now comes the equation of the directrix. Now there are 2 of them, so we are going to call it directrices. So equation of directrices. Fine. So equation of directrices, this side and this side. So one is x plus a by e equals to 0. The other one is x minus a by e equals to 0. So if we club these 2 together, now why I am clubbing these 2 together here? Because just to save the space, it will be x plus minus a by e equals to 0. Fine. Now comes the latest rectum. Now what is latest rectum? Latest rectum is a chord passing through the focus and it is perpendicular to the major axis. That is called a latest rectum. The same thing we had for your parabola as well. Now here, as you can see, I will have 2 of them. In ellipse we are going to have everything 2 2. So therefore the latest rectum, the plural of latest rectum is called latera recta. These are Latin words, so we can't judge it by our English knowledge. So latera recta, that is the plural of latest rectum. And we are trying to find out length of the latest rectum or latera recta. So length of lateral recta, that is this length, is 2b square by a. So in both the cases it is length, so there is no question of being positive or negative. So in both the cases the length of the lateral recta or each of this lattice rectum will be 2b square by a. Fine. Now the same thing is going to be turned upside down. If I take y-axis as the major axis, so this will become, shape will become something like this. So what will happen? Everything is going to go on the other side. So I am just going to give you the equation. I am not going to draw it anyway. So because drawing this in itself took me very hard, because drawing this ellipse, I'm not good with drawing. So just give you the picture, it looks something like this. The thing will, shape will come something like this, so you can understand how it is going to be. So now the equation of the ellipse with center at origin and y-axis as the major axis, then the whole thing will be turned upside down. So it will become y square by a square and x square by b square, right? So a square is your major axis and b square is your minor axis. So a and b, we are just keeping it fixed. Now there will be many book you will be finding, they have kept the equation same. They have just mentioned a is less than b and b is less than a, something like that. So that can be confusing at times. So better not to do that, better to keep this notation for major axis and minor axis same. I'm just changing the x and y, that helps. Okay, so in that case what happens, the center will be at 0, 0 as always. The vertices will be changed. Now I am clubbing it together, that will help me. So it will be 0, plus minus a, right? Foci will become 0, plus minus ae, and this will become y plus minus ae. Length of lateral rectum will remain all the same, it will never change. Now I need to understand, you may have this question, from where I am going to get the value of E, that is the eccentricity. To find the value of eccentricity, we have a formula. The formula is E is equals to under root 1 minus b square by a square. Fine. So this is the your formula for finding the value of E, that is the eccentricity. Fine. So that's the idea of ellipse where the center is at origin. Now what happens if the center is not at origin, if it changes from origin to some point else? So let this point be instead of origin, so I am doing it for one, the other will follow as it is. Let it be h comma k. So let me just change it. So the center is no more at origin, the center is at h comma k, and the x-axis is your major axis. So what happens? Just follow the same idea that we had in case of parabola. So it will become x minus h whole square by a square plus y minus k whole square by b square equals to 1. The idea is same, right? And major axis as x-axis, definitely not. Major axis is parallel to x-axis. Fine? Because if the center is some arbitrary point h comma k, so it is not going to lie on the x-axis, it can be anywhere else. So therefore I am considering that the equation, I am trying to find out the equation of the ellipse whose center is at h comma k and the major axis is being parallel to x-axis. So these are not x-axis and y-axis once again. So just tally it. So now what are the things which are going to change? The things that are going to change is this will be h comma k, that is the center. Now what will be the Vertex, now see, if this is h comma k, this distance is a, so this will h plus a, h minus a. So this is h plus minus a comma k. So it is more like you are adding h and k to all these coordinates. That will only give you the values. Similarly, it is h plus ae, h minus ae. So h plus minus ae comma 0. I mean sorry, k. Right? Then equation of directrix. Now see, here I have h and k and this is a by e. So it will become x plus minus a by e equals to h. So this part is h plus a by e, this part is h minus a by e. So therefore it is x plus minus a by e equals to h. And length of lateral rectum, it will remain all the same, so there is no change in that. And similarly, you can write the same thing when the major axis is parallel to y-axis. Fine. So now let us move on and solve few problems. Let us take the first problem, chronologically the fourth one. So you have to find the coordinates of foci, vertices, major axis, minor axis, the length of latus rectum and the eccentricity of the following ellipses. So these are the examples taken. So let us start one by one. In the first case, it is already given in that form, x squared by a square plus y squared by b square equals to 1. So the value of a is 5, the value of b is 3. So from there, what is e? That is the eccentricity under root 1 minus b square by a square. So that is 4 upon 5. And also you can check that the eccentricity is coming out to be less than 1. Now vertices, that is plus minus a comma 0, so that is plus minus 5 comma 0. Foci, that is plus minus a e comma 0, so that is plus minus 4 comma 0. Length of latus rectum 2b square by a, so that is 18 by 5 units. Major axis 2a, minor axis 2b, that is 10 and 6. They didn't ask you to find the equation of directrix, so let that be. Even in case if you would have had to find out, so that would have been x plus minus a by e equals to 0. Similarly, if I take the second one, so all we require is to transform it into the standard form, but here in this case the major axis is along the y-axis, so therefore we are writing it in a different way, that is y square by a square plus x square by b square equals to 1, just to ensure that we keep the formulas all the same. So the value of a is 10, value of b is 5, so the eccentricity is root 3 by 2, and so on so forth. You can just find all the different things that we require to find out. So vertex is 0 comma plus minus a, focus or the foci, that is 0 plus minus ae, and length of latus rectum, that is 2b squared by a. Fine. Now let us move to number 5. Now question number 5, find the center, length of axis, eccentricity, foci, vertices, length of I think length of axis is repeated twice, sorry for that. Length of latus rectum, equation of directrices of the ellipse, x square plus 4y square plus 2x plus 16y plus 13 equals to 0. So now it is not given in the standard form. We need to first reduce it down to standard form and then we need to work on it. So we start off with this, x square plus 4y square plus 2x plus 16y plus 13 equals to 0. Then we do what? We do some arrangements. So x square plus 2x that we take together, so we take 1 along with it, that completes the square. Then 4y square plus 16y is given, so if we take another 16 with it, and we do the adjustment by subtracting that 4, so you can do it all by yourself. You understand how to do completing the square method. So from there we get x plus 1 whole square plus 2y plus 4 whole square equals to 4. We divide it by 4 and then we just cancel out any factors we have, so we come across x plus 1 whole square by 4 plus y plus 2 whole square by 1 equals to 1. So now if we tally this, so this is basically x minus h whole square by a square plus y minus k whole square by b square equals to 1. So therefore from there we get that the center is at minus 1 comma minus 2. The value of a is 2 and b is 1. Fine. So that will be the semi-major axis and semi-minor axis. Then eccentricity is root 3 by 2 again. And from there the vertex will be h plus minus a comma k, so just follow that. Then foci, that will be h plus minus ae comma k, and equation of directrix, x plus minus a by e equals to h, so a by e, that is 2 in this case. Okay, so here I have made a slight mistake. So here I have just made a mistake. So this is x plus minus a by e. So a by e is basically 4 by root 3, that is equals to h. H is minus 1. So that should be the equation. So please do rectify this. And once we have done so, then the length of major axis and minor axis, that is 2a and 2b, and length of latest rectum, if we try finding out, that is if we go for the length of latest rectum, that is 2b square by a, and if we do the calculation, that comes out to be 1. Next problem, find the equation of an ellipse whose center is 0 comma 0 and major axis is on x-axis. So these are the two things given with additional criterias. The first one is vertices given to be plus minus 13 comma 0 and foci given plus minus 5 comma 0. Length of latest rectum, length of the major axis given 8 and the eccentricity given half. In the next case, the eccentricity given root over of 2 by 5 and passing through the point minus 3 comma 1. So let us start off with the first one. Now in all the cases, I can definitely consider that the equation of the ellipse bx square by a square plus y square by b square equals to 1, because it is told that the center is at origin and the major axis is x-axis. Now it is given that the vertices are plus minus 13 comma 0. So that means the value of a is 13, that is given. Foci is given to be plus minus 5 comma 0, so the value of AE is 5. So from here I can find the value of E to be 5 by 13. So if we go on solving, we get the value of B as 12. So therefore, once we get the value of A and B, we are done. We can put it back into the equation, and therefore the equation becomes x squared by 169 plus y squared by 144 equals to 1. Next, number 2. Length of major axis is 2a, so therefore the value of a is 4. Now the eccentricity is given half, so from there I can get the value of b. B squared, that much is more than enough, so b square is 12. So a is 4, that means a square is 16. So from there equation is x squared by 16 plus y squared by 12 equals to 1. Okay. Now the third one. Here it is given that the eccentricity is root over of 2 by 5. So 1 minus b square by a square, that is equals to 2 by 5. So from there I can find a relationship between a square and b square, that is 5b square is equals to 3a square. Now it is also told that it is passing through the point minus 3 comma 1. So therefore I can get another relation between a square and b square, that is 9 by a square plus 1 by b square equals to 1. Right? Now let us put back the first relation into this second one and do some calculations. So from here I get the value of a square as 32 by 5. So from here I get the value of b square as 96 by 25. Please go on checking the calculation because I have done everything in a hurry. I'm sure that you have understood the process, because process is important here. Once you understand the process, the calculation, obviously you have to get it right for sure, but understanding the process is very important, because you can do your calculation at your own time, but obviously in a limited time frame for sure. So once we know a square and b square, just put it back. So therefore from there, if we do a little bit of calculation, we get the equation as 15x square plus 25y square equals to 96. Okay, so now we move on to hyperbola. Now once we have already understood ellipse, understanding hyperbola is very easy, because it is just like the counter flip side of the same coin, if you have understood ellipse. Now the situation is something like this. There is a path obviously given by a moving point, such that, again the same idea, there is a fixed point S, there is a fixed line. Now this is O, which is the center. Now calling it a center is a very uncharacteristic thing, because it is an open curve, both sided curve, and also the center lies outside the curve, so which is something which we are not used to. We have always known that the center exists for a closed curve, but here is one kind of a curve where the center is not inside the curve, and it is not a closed curve. Fine. Now the idea is all the same, that there is a fixed point, there is a fixed line. This is not y, sorry, this is y. So the distance of any point from the fixed point and the fixed line bears the same ratio, bears a ratio, that is SP equals to EPM. Now what makes the difference is that in the case of hyperbola, this ratio is greater than 1, and it is pretty visible also. You can see that this distance is more than this distance. So distance from the fixed point is more than the distance from the fixed line, right? So now let us directly move on to the equation, and then from there we are going to discuss everything. Now before we go into the equation, let us understand the axis on which the focus, vertex, everything lies. That is called the transverse axis. So we are not going to call it major axis and minor axis, because that idea doesn't apply here, because it is not necessary that this value has to be more than this value. No. And the axis perpendicular to transverse axis passing through the center is called the conjugate axis. Fine. It is called the conjugate axis. Fine. Now conjugate axis is also called imaginary axis. Why? Because you see, the axis which is being called as conjugate or imaginary, it doesn't have a single point of the parabola on it. I mean, single point of the hyperbola on it. I mean, the path of the hyperbola doesn't intersect this axis. That is the reason why it is called conjugate or imaginary axis. So now let us talk about the equation. So equation of a hyperbola with center at origin and transverse axis x-axis as x-axis. Right? We are going to talk about this first. So I have taken the center at origin, the transverse axis is x-axis. So in that case, the equation becomes x square by a square minus y square by b square equals to 1. Where 2a is your transverse axis and 2b is your conjugate axis. Length of the transverse axis, length of the conjugate axis. Fine. So from this equation, what are the things that we come across? First is the center, of course. The center is at origin, so this is 0, 0. Vertices, same way, plus minus a, 0. But the difference is, you can see a is this much. Here it is minus a. So in case of ellipse and parabola, the vertex is always to the left of the focus, but in this case I can see that the vertex always need not be to the left of the focus, it can be on this side as well. Then the foci, same thing, plus minus a, 0, same thing, and equation of directrices, that is x plus minus a by e equals to 0. So idea is all the same, the whole process is all the same, just the equation looks different. Why it looks different and all these values are going to be different? Because e is greater than 1. That is the reason why. And so what will be the formula for e? E is basically root over of 1 plus b square by a square. So you can see it is how easy to tally. If it would have been minus, in that case it would have become ellipse, and if it is plus, then it becomes hyperbola. And obviously length of lateral rectum, each of the lattice rectum, that is the same thing, 2b square by a. Fine. And I'm not going to go in details of this because hyperbola in itself is a pretty complex topic, and even the likes of Newton, Einstein, they themselves have done a lot of research on this particular type of curve, and it has been also found that there are some celestial bodies in the universe which follows these hyperbolic curves. They are very complex curves. We know celestial bodies to follow circular path, we know them following elliptical path, we know them following parabolic path, the comets. But there are certain objects which also follow this hyperbolic path as well, and that has been a huge topic for research, and even the scientists are still working on it. So hyperbola is a very complex kind of a curve, so we don't have to deal with this much with it, because frankly it is beyond our scope of discussion, because hyperbola is such a thing. So just to give you the basic idea, this is it. Now obviously if it becomes y-axis as the transverse axis, then this will become y square by a square minus x square by b square equals to 1, and this whole thing will change, which you can tally from the ellipse part. So just see the part where we have done ellipse, from there you can just tally it. This part will just go flip side. And similarly, in case of the center is not at origin and at some arbitrary point h comma k, then again it will become x minus h whole square by a square, and this will become y minus k whole square by b square. Clear? So that's it. So this is our theory part for hyperbola. We are just going to have very simple problems, given that we have the reduced syllabus, so we are not going to go deep into it. Now just I'm going to give you a small idea. Let me just erase the whole thing first. Okay, so now I'm going to talk about a small thing, that is now I'm just going to give you a small idea of it. We are not going to go in deep into it. So any equation which is of the form this ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equals to 0. This is called a general equation of second degree. Why second degree? Because the highest power of the variable present here is 2. Now, this particular equation gives you all the different types of conics that we have. Now, how to understand? Now, there are the things. If a is equals to b, let us start with 1. If a is equals to b and age equals to 0, if I have a situation like that, a equals to b means the coefficient of x square becomes equal to coefficient of y square and the value of h is 0, then that is called, then that gives you a circle. Correct? 2. If h square is equal to ab, if it becomes equal to ab, then that gives you a parabola. 5. 3. If h square is less than ab, something like that happens, it gives you an ellipse. 4. If h square is greater than ab, it gives you a hyperbola. Now you may be thinking that why circle? Now circle is also a conic. Let me tell you, many have this wrong idea that circle is not a conic, but it is actually a conic. And also I haven't discussed the main idea that why it is called a conic. So the idea is it has generated from a cone. If I have a cone and what I do, I take different cross sections of the cone, I will end up with all these different types of figure. How? If I cut the cone parallel to the base, obviously what kind of cone? It is a right circular cone. Let me just tell you that, right circular cone. Not any other kind of cone. It is a right circular cone. That has to be mentioned. Why right circular? Right circular means the tip of the cone is perpendicular to the base. That is why it is called right. And circular means the base is a circle. So that these two facts has to be mentioned. Now, if I am taking a right circular cone and I am cutting the cone parallel to the base, then whatever I get is a circle, because the base is a circle. If I cut parallelly, I will get a circle. If I do not cut parallelly, instead of this parallel cut, if I cut it something like this, obliquely, any other way, then I am going to end up with an ellipse. If I am cutting it parallel to the slant height of the cone, so say something like this, which is parallel to the slant height, then I am going to come up with a parabola. And if I cut it parallel to the height of the cone, so this is your height of the cone, and if I am making a cross section parallel to it, then whatever I am going to end up with, that is your hyperbola. Now this is a fun project you can try doing at home by making a model out of it. So you can just make a model of, you can make a cone and then make all different cuts, and you can just check it for yourself that you are going to get all these 4 different types of figures, cross-sectional figures. So that is why circle becomes also a conic. So in some books they are given separately, but circle is also conic. Right? But yes, obviously you can say that the circle, the definition of circle doesn't fit the definition of all these other figures. Why? Because circle doesn't have a focus and a directrix, but all these three have. Now there is also different classification of conics, degenerated conic, non-degenerated conic, so we are not going deep into it. So due to that reason, circle is a bit different from all these other three different kinds of conics. So let us not deal with that. Fine. So whenever you are given a question like this, say you are given a question like this, say you are given this equation and you are asked to identify what kind of conic it is. Is it a parabola, circle? They are not going to give you circle because it is not to be considered into this, but yes, obviously, why not? Why not? If you are given this kind of an equation, so you have to go on testing all these things and you have to check if it is coming out to be a circle, parabola, ellipse or hyperbola. Fine. So that's it. So this is the end of the theoretical part of the chapter, and let us move into the problems. So the first problem of this topic: find the eccentricity, center, foci, vertices and directrices of the hyperbola. So by now you people have already got used to this idea. So these are the questions given. So let us not solve all of them, so you already know how to do it. So the first one, it is x square by a square minus y square by b square equals to 1. Now in case of hyperbola it is pretty easy, because whichever the term is positive, that is the transverse axis, whichever is the negative is the conjugate axis. So therefore from there I get the value of a and b as 4 and 3. So from there, what is the eccentricity? It is 1 plus b square by a square, so that is 5 by 4. Now from here I know the center is at origin, the foci, that is plus minus a comma 0, so that is plus minus 5 comma 0, the vertex, that is plus minus a comma 0, so that is plus minus 4 comma 0. Equation of directrices, so that is x plus minus a by e equals to 0, so that is x plus minus 16 by 5 equals to 0, right? Similarly, if we do the second one, in case of the second one, now it is y square by a square minus x square by b square equals to 1. So a is 3, b is 3 to 3. From there, e is 2, center is 0, 0, foci. Now obviously here the y-axis is the transverse axis, so therefore it will be 0 plus minus a e. So that is 0 plus minus 6. Vertex is 0 plus minus a, so that is 0 plus minus 3. Equation of directrices, y plus minus a by e equals to 0, that is y plus minus 3 by 2 equals to 0, and that's it. Let us move to number 8. So we are going to do the similar thing, that is we are going to find the center, length of axis, lattice rectum, foci, vertices and equation of directrices of the hyperbola. 9x square minus 16y square minus 18x plus 32y minus 151 equals to 0. So the same thing, we need to just reduce it down to the standard form. Then from there find the center, then the transverse axis, then the conjugate axis, then the lattice rectum that we have found out at the beginning. We could have done it later as well, but the most important thing is to find the eccentricity, that is under root 1 plus b square by a square, and here it is 5 by 3. So from there I get the foci, I get vertices, I get equation of directrices. So that's it. So that is all we have. Now in case of hyperbola, finding equation of hyperbola happens just the same way as it happens for your ellipse. So you can just go through the problems the same way. So that's it. That ends the chapter. And as always, if you have any doubt, get it clarified. Thank you.